Alrighty, so we have Unit 5, exponents. Just go ahead and tune in. Some of this will be new stuff to you. Alrighty, so exponents. It says a number that shows how many times to multiply the base. So if we take a look here, here's the base. That's the number 5. You're going to multiply it 3 times. That's what this part tells us. Now, I know you've probably seen this before, so this part's not exactly new. So again, what that really means is 5 times 5 times 5. Now, that's not 5 times 3, making it 15. 5 times 5 is 25, times another 5 is 125. So again, this is the base, this is the exponent. It's how many times you multiply that base. Again, it's not 5 times 3. Alright, he's talking here about a perfect square. Multiply an integer by itself to get a perfect square. Now I'm going to give you a whole sheet of these, so make sure you do ask me for that when I give. Make sure I don't skip giving those to you. So in this case, again, we know that 5 squared means 5 times 5. So numbers like 25 are considered perfect squares. Numbers like 36, because that's 6 times 6, right? Numbers like 49, because that's 7 times 7. These are perfect squares. Numbers like 24, not a perfect square. I can't come up with an integer that I can multiply by itself to get 24, so not a perfect square. A perfect cube's a lot like a perfect square, except that this time, right, it's 3 times. So this one, again, we know 5 cubed is 5 times 5 times 5. So numbers like 125 that are perfect cubes because it's 5 times 5 times 5. Other examples are numbers like 64. That's a perfect cube because 64 is 4 times 4 times 4. Right? Or numbers like 8. Because it's 2 times 2 times 2. Notice 3 times that whole cube thing. So 2 cubed is 8. All right, so here we have a radical expression, not just something that people in the 80s said. A mathematical expression that contains a radical. This is the radical symbol. This number under here is called the radicand, an expression under the radical symbol. It could be a variable, it could be a number, it could be, variables and numbers, a mixture, it could be addition, it could be all kinds of stuff. You should see what I do to the advanced kids with this. Index here, that's the degree of the root. If I write nothing, that's squared. So like if I write it like this is the square root of 4. But if instead I select the number 3, that's the cube root of 8. Or I could have the 5th root of, 421, right? So what number times itself 5 times gives you 421? Give a hint. That one is going to be an irrational number. So, but again, so index, radicand, radical symbol. The whole thing together is called a radical expression. Okay, square root. Again, mentioned before, probably the most common one, the one you're going to see the most often. A number that can be multiplied by itself to equal a given number. The opposite of squaring something. And I'm going to give you a whole sheet of these. So I'm going to pick a different color. Here we go. So if I talk about the square root of 64, right, that's 8 because 8 times 8 is 64. Or the square root of 196 is 14 because 14 times 14 is 196. Okay, so the idea of a cube root is a lot like a square root. Notice the index, right? The index here tells us I need 3 numbers when multiplied by itself equals 125. We already talked about earlier here that we know 125 is 5 times 5 times 5. So the cube root of 125 is the number 5. Again, just like if I say I want the cube root of 64. That means I'm going to have 4 times 4 times 4 equals 64. We know that, right? So the cube root, these aren't two actually equal here. The cube root of 64 is the number 4. And again, there's a lot of these. As many as you want to come up with, there are available. And I do have a sheet of these for you. Make sure I give that to you.